test. There's a few people that struggled, and I want to go over how to solve this guy in full. First things first, I'm always going to try and label AHK points and the zeros. If I look at the information provided in this table right now, you'll notice that there's no zeros, so it's likely not going to be in that form right there. My attention is drawn to these two y values that are the same. And so I just did a little sketch right here just to try and think about what that might look like, right? Right there. Because the y values are the same on this guy, I can actually find out the axis of symmetry. Because I can just ask myself, like, what is in between those two guys? So if I did, it's not really zeros, but this formula is still going to apply if I take the x value of this one and the x value of that one, right? So if this is negative 8 and negative 20, and this is 16 and negative 20, I'm just going to evaluate the x's to get the middle of this function. So it's just going to be 8 divided by 2, h is equal to 4. So if you see that, and again, you don't have to use this formula, you can also just kind of eyeball it and do some logical reasoning. But if I know that my h is 4, well, looky here, that value there is 4. Well, I know that for h and k, right, the h is the x value of the vertex. The k is the y value of the vertex. So I also know that those two are always paired together. So if I found h is 4, and this is telling me that 0.4 and 16 exists on this function, then that makes this guy h and that guy k. So the other way to kind of see it maybe, and the easier one, or easier method, is to try and ask yourself, like, what is the distance between negative 4 or negative 8 and 4? Well, it's 12. And what is the distance between 4 and 16? Well, it's 12. If the distance is the same, that also identifies that as my h and k. So I have 4 and 16 now. So this whole skill set is being done just to identify what the vertex is, which means I'll be using vertex form in this case. So what point do I have? Well, I can just use any one of these guys now. So I can even use the 22 and negative 65. So let's use that. 22 minus 4 squared, and then plus 16. A lot of mistakes that I saw are related to this right here. Get this guy out of the way first. So if you do that, and I go, well, I'll be subtracting 16 from both sides. I've got 81 is equal to a, and then 22 minus 4 would be 18 squared. So I'm going to get that k out of the way and combine it with the y first. It's just going to make my life a lot easier. Now I'm going to have 81 is equal to a 324. And now I can just divide by 324 on both sides. A is equal to 81 divided by 324. Keeping that in mind that I forgot to write in that these guys were going to still stay negative. 81 would be negative. And so my a value would be negative 0.25. Always make sure you double check that. I knew that this guy faced downward just based on the points that I had. So mentally, I was trying to validate my answer there. And that's how I knew to go back and double check that guy. At the end of this, that's not the final rule. That is the final answer I was looking for right there. Now, the next guy is literally just diving into that vocabulary stuff. So what's the important thing? I have to know that initial value of negative 7.2 is actually a point. The initial value is the y-intercept. It exists where x is 0. So if I list a, h, k, x, y, z1, and z2 here, well, I can start by including 0 and negative 7.2 as a point because it said initial value. The positive between the following intervals tells me that that is Z1 and that is Z2. That's just something that should be on your memory aid, that where it is positive is zeros. So the actual value is -9 and 4, which means this guy will be using zeros form, x minus Z2. Find this easier to work with than the other form, just because you're not having to move around the k. It's literally just doing brackets, multiplying, and dividing. So I can just plug in what it is that I know. Do not forget that when I inject that 0 in, I'm putting in the opposite value from its real value, because this formula says subtracting Z1. So that means when I inject this next one, it would be -4. So -7.2 A, this is going to end up being 9, -4. -7.2 is equal to A times -36. And then now I'll just divide both sides by -36. And I'll get 1 point, or 0.2, sorry, 0.2. So what is my final answer? It's going to be 0.2 x plus 9 x minus 4. That's the final answer. Now, last but not least, the long answer guy here. This is a pretty simplistic one. There's a couple of tricks to it. We're going to start by labeling our A, H, K, X, Y, Z1, and Z2. To start out, because it's saying it's launched from the ground and reaches a max height of 90 meters in 15 seconds, it doesn't say it, but we can assume that it starts at the origin, right? Time was 0, height was 0 when they set it off. Now, the important part. A lot of people wrote this as 90 and 15, but we know that max height is always K. And we know that whatever X value is paired with that, so 15 seconds, that one is going to be the H. So that was the big thing that people were confusing, is my H is 15, my K is 90, because it says max height is 90. So what it's telling you is that height is 90, axis of symmetry is 15, which you can even extrapolate. A lot of people are even able to reason that, well, then that would make that 30 and 0, right? Because this distance and that distance have to be the same. So if I'm starting at 0, halfway is 15, the second 0 would be 30 and 0. Not necessary to solve for this guy, but just something that maybe you could use on a future question. So what I want to point out is that because it starts at the origin, that means that's a point that I can use. So if I look at it, I have H, I have K, I have a point. So my step 1 is always just like label what I have. And then step 2 is always going to be find rule. So that means find A. So what I'm going to do here, A x minus h squared plus k, I'm using vertex form. I'm using 0, 0 as my point. And I'm putting in my h and my k. And again, as a reminder, biggest mistake I'm seeing is people aren't moving that out of the way first, right? Second biggest mistake is here when I squared -15. You're trusting your calculator and not your elementary school math skills, knowing that negatives and negatives multiplied gives you a positive. So that means now I would have positive 225. So I'll be dividing both sides by 225 and get an A value of -0.4. It mattered that that guy turned positive because this function is facing down. The A value needs to be negative. If the A value you got wasn't negative, everything from here on in is going to be even more difficult. So always look to your diagram. Always look to your diagram. So I didn't just find A is -4. I found the rule. I found the rule right there. So now what we're going to do is actually use that rule. So step 3 is always use rule. Now let's break down what the question's actually asking us here. It says that there's a rocket that launched, reached a max height of 90 meters in 15 seconds. So that's why those two things were paired together as 15 and 90, by the way, because it tells you it reached that max height at a specific time. And it's telling you here that time is X and height is Y. Time is always going to be your independent variable. Upon its descent, the rocker ignites at a height of 87. That means we don't know the time, but we know the height. So we know the Y value. And the only other thing that we know in this case afterwards is that 9 seconds after it ignites, it extinguishes. So this is going to be whatever answer I get for X plus 9, and that is what I'm really looking for in the end, is what is the height of it when it is extinguished? 3. At what height will the rocket be extinguished? So let's reason through it. Use rule to find X, question mark, when Y is 87.5. So this is why we wanted to stick with vertex form, because it just makes it easier for us. I'm going to write out the rule in vertex form here is equal to negative 0.4 x minus 15 squared plus 90. So what I said is we're looking for when y is 87.5. So let's put that in. Now, it's entirely up to you how you want to run with this. I'm going to show you just the formula way. I mean, that's my preferred method, but it doesn't have to be yours. So if that's the case, my main goal next is to always, in this case, set this guy to 0. Set to 0. I can't use this next formula. Basically what it's doing, if I go up to the diagram here, the formula I'm going to use helps me traditionally just find out what my zeros are from any given rule. It'll also help me find like any x values at any specific y value. So for example, right here, I'm looking for what is this x and this x, right, when y is 87.5. I'm only going to be using this answer, but the formula I use is going to give me both. I'll just have to choose which one that I want to use. So you'll notice here, if I plugged in the original negative 0.4, 15, and 90, I would have got 0 and 30 out of this formula right here. But I don't want to find out the zeros. I wanted to find out what was x when y was 87.5. So what that means is I set that equation to 0, moved over the 87.5. Now I have a very clear A, H, and a little bit of a different K. So let's plug all those things in and see what happens. The real value of H plus or minus square root of negative 2.5 divided by negative 0.4. This is why it was important that my A value is negative. Otherwise, this guy here wouldn't have worked. So now I'm going to get 15 plus or minus the square root of 6.25. From here, take the square root, 2.5, and now I can branch off. So I'll have 15 plus 2.5 is equal to 17.5, and I'll have 15 minus 2.5 is equal to 12.5. Well, I wanted the bigger answer, so I'm going to accept the 17.5 and reject the 12.5. So we're only using one based on this scenario. And so the diagram, again, is what becomes super helpful to us. Now, last but not least, what I am going to do is take a look up here again. I can include what it is that I just found. So 17.5 was the x I was looking for, which actually means this was 17.5. So let's actually just find that now. Step 5, find y of extinguish. So x plus 9 is equal to the time that it extinguished. So 17.5 plus 9 is going to give me 26.5. That is the time it extinguishes. So now I can use the rule that I was provided, or that I found, negative 0.4. The x is going to be 26.5. The H isn't going to change. The K isn't going to change. And now we just basically do our bed mass here. So I'm going to go negative 0.4 and have 11.5 squared plus 90. Do my multiplication. So y is equal to negative 0.4, 132.25 plus 90. Multiply that guy by 0.4. Y is equal to negative 52.9 plus 90. So y would be equal to 37.1. So that would be the final answer. That is the height of this guy when it extinguishes. So I'll just back out and leave that up there for a couple seconds. Feel free to email me, message me on Teams if you have any questions about this. I'll post this document as well along with the video. Good luck on the retest.